This is an example of what we call a plug-in problem. And we call this type of problem a plug-in problem primarily because the values of the quantities change depending on what you plug into them. For example, here, quantity A and quantity B are going to have different values depending on what we choose for P and what we choose for N. Now, whenever you encounter one of these plug-in problems, do yourself a favor. Start the problem by plugging in very simple values, values that are easy to work with. For example, if this were my problem, I'd let n equal +1, and I'd let p equal 1/2 because those numbers are simple and easy to work with. So let's plug those values in here. In the case of quantity A, we'd get 1/2 to the first power. And remember, any value to the first power equals itself, so quantity A would equal 1/2. And in the case of quantity B, we get 1/2 to the -1 power. Now remember, a negative exponent means flip your base and make the exponent positive. So if we flip our base, 1/2 would become 2/1. And when the exponent becomes positive, we get 2/1 to the first power, which is 2 to the first power. And of course, 2 to the first power is 2. In other words, when p is 1/2 and n is +1, quantity B is bigger than quantity A. Having said this, though, we're not done with the problem. When you do plug-in problems, you can't just plug in one set of values. Once you plug an initial set of values like we've done so far, your mission becomes something different. You want to see whether you can disprove the relationship you've already been able to establish. For example, here, we are able to show that B can be bigger than A. The question is, can we make these quantities equal? Can we make A bigger than B? We've got to plug in further examples before we are satisfied with our solution. So as the next step, let's see what happens when P is 1/4 and N becomes +2. In the case of quantity A, we'd get 1/4 squared, and 1/4 times 1/4 is 1/16. And in the case of quantity B, we'd get 1/4 to the -2 power. Again, remember with negative exponents, you want to flip your base, and then the exponent becomes positive. So when we flip our base, 1/4 becomes 4/1, and the -2 becomes +2, leaving us with 4 squared, which is 16, again making quantity B bigger. And as a last step, let's go ahead and plug in one last set of values. Let's say P is 1/10 and N becomes 3. In the case of quantity A, we get 1/10 to the third power, which is 1/10 times 1/10 times 1/10, which is 1/1000. And in the case of quantity B, we get 1/10 to the -3 power. When we flip our base and make our exponent positive, we get 10 to the third power, which is 1,000. And what this is showing us is that no matter what we're choosing, B is bigger than A. And at this point, the basis for this relationship is fairly clear, right? No matter what we choose for quantity A, we're going to end up with a small fraction. And what's going to happen with quantity B? That fraction is going to be flipped, making it a whole number. And then we're going to take that whole number and put it to an exponential power, making it bigger and bigger and bigger. And that ultimately is the reason here that B is bigger than A, proving to us that B is the correct answer.